Hi everyone, that was Maps by Maroon 5, which is indicative of this talk because I'm going to show you some maps. So my talk is called Data Science, Make It Spatial, and I work at the Center for Spatial Data Science, so I thought it would look stupid if it was like Data Science, Make It Spatial, and then it was Angela Lee, Center for Spatial Data Science. So it says University of Chicago, which is where I work. So without further ado, a little bit about me. I am the RSpatial advocate at the Center for Spatial Data Science at UChicago, which is a mouthful. Basically, I'm a wannabe Mara Averick, and I look at a lot of maps. So that's what that job is. I also help researchers do their research, whatever. I just want to be Mara Averick. Okay, I'm the founder of Our Lady Chicago, and we started last year, July 2017. This is actually a photo from the launch. In it, I'm speaking, so I've done this at least once before. I wrote a thesis using spatial econometrics about property values in Detroit under Luke Anslin, who literally wrote the book on spatial econometrics. It's called Spatial Econometrics. I was going to talk about spatial econometrics, but I learned from Econometrics B that you should not talk about econometrics after 3 p.m. in the afternoon. So I'm just going to show you some nice maps. So I'm going to talk a bit about geography. Geography, when most people hear this term, this is what they think of. This is a map from Lord of the Rings. But I'm here to tell you that geography can and does involve data science. Woohoo! Look at this cool app. Geography currently is used in all sorts of decision support tools. We work with public health officials. We do cutting-edge social science research. We look at air pollution, and I think Roger's talk about air pollution actually dovetails with some of the work that we've done at our center with Chicago air pollution. And I believe right here, this is an app about medical services. So before we get to the really cool, interesting part of making shiny apps and things with spatial data, before we get to that, we have to do exploratory spatial data analysis. What is that? What is ESDA? It basically is making a ton of maps. This is not how I make maps, by the way. When I searched map making, all there was this person putting pins in a map and then linking string to it, which is not part of my day-to-day routine, but it looks very meditative. So I might start doing this if I get really frustrated with my code one day. Okay, so the way I thought I would demonstrate what ESDA, or exploratory spatial data analysis, was by looking at data. So what I did was pull the crimes in DC in the last 30 days from the DC Open Data Portal, and I read it into R. The wonder of R now is that you can actually use it as a GIS. So you can do a lot of the GIS work that you used to do in, for example, ArcGIS or QGIS in R, and you can work with spatial data in R in ways that you could never have previously. SF was released last year in 2017. It's really sort of revolutionized how I work with spatial data. So what I'm doing here is essentially reading in a GeoJSON, which is like a JSON, but has geo in it, and reading it into R. I'm looking at the observations. If you're familiar with SF, it is essentially a data frame or a tibble, and on the end of it is tacked one column that's special. It's a geometry column. And these can be points, polygons, and other things. Of course, the first thing I wanted to do was make a map. So this is all the crimes that happened in DC in the last 30 days. I just threw it into Leaflet. The first thing I want to do is I want to see my data. I want to look at it. This is the equivalent to making a scatter plot and ggplot. You just want to look at your data, just see what's there. And I'm able to zoom in and out because it's in Leaflet. Maybe I can't zoom in. OK. Whew. Very exciting. So I think this is where we are right now. No crimes. Nice. OK. All right. Just we wait after. Maybe after this conference there'll be some. I don't know. I think, well, maybe people just haven't reported in this area. Who knows? Okay, so I've made a map. Now I'm like, ooh, I don't like dots. I like surfaces. So I'm going to change it into a heat map. So I'm using the leaflet extras package, and I'm like, ooh, look, I've made this like cool heat map of things. And I'm like, you know, there's hot spots everywhere. I feel like I'm you know, in some sort of TV show where we're all like looking at hot spots and like pinpointing crimes. Cool, very fun. The problem with heat maps is this. And I don't know if you can see this or if you've seen this XKCD comic before. What it essentially says is if you plot counts by area, it often just reflects population. So in this comic, we see that our site's users has this map. The second one is subscribers to Martha Stewart Living. And the third one is consumers of furry pornography. And this guy is saying the business implications are clear. So the caption, of course, is geographic profile maps, which are just population maps. So counts are not that great. You know, they can give you a sense of, you know, where things are clustered. You can get an idea of where things are. But if you want to do actual analysis, you want something that's a little bit more spatially intensive. I want to adjust for population. The thing about population is population data is collected in very specific units. And those units are census tract polygons. The US Census you know, happens every 10 years, counts all the people, and counts them in these little, in these strange little buckets called census tracts. Census tracts are the smallest unit that you can get population data at. You can get these in larger chunks. You can have blocks and block groups, and they're slightly larger. But tracts is generally the most granular form of data you can work with. So, for example, if we zoom into where we are, you can see that the mall is just one giant census tract, which makes sense because no one really lives on the mall. And you know, there's some other tracts. So, could do that. Maybe I want to add crimes as a layer. And so you can see in my code that I've just put another line that says add circles. The crime data with you know, a colored red. I can zoom in a bit more and take a look at, you know, where the dots are in relations to tracks. I notice that there might be some you know, more dots in this little area right here. For some reason in Georgetown, there are a lot of crimes reported. So I'm like, cool, this is interesting. But there's no way that I can, you know, sit there and count each one of these dots by hand. And that's where spatial join comes in. So the question I'm really asking is, how many crimes happened in each tract? This is a question of spatial aggregation. So if you have points and you're going to a polygon, you're aggregating up by the spatial unit. Also called point in polygon analysis. That's essentially what geographers are saying when they say point in polygon. There are points which represent crime, you know, houses, or any sort of data you might want. And then there are polygons, which are, you know, census tracts, block groups, counties, zip codes. So I really want to count points in the polygons. Normally, you might do this with a GIS software. You can now use R as a GIS software. I'm going to use this thing called spatial join. This is from the SF package again. And so I'm going to spatial join essentially the crime and then the tracts. And I want to pull out the census tract from the census tract geographic data. What this does is, instead of joining on a common column, it joins on a common geography. So for all the points on the left, if they fall within one of the geometries of the polygons on the right, so DC tracts, they will be joined to that. So a point, I should have shown an example of this. I'll show you what the data frame looks like in a bit. If a point falls within a polygon, it will have the associated census tract attached to it. So I get an error. stcrsx equals stcrsy is not true. What does this mean? You know, I just wanted to join things together and have it work. I don't understand. Warning, the worst part of working with spatial data is ahead. Projections! Julia Selge said this well. This is a tweet by her saying, me making maps but not really knowing anything about map projections. I have no idea what I'm doing. All right. Dealing with projections and spatial data analysis is similar to data munging. You don't like it, you're complaining about it, and I am the 10th, 12th, 15th person to complain about data munging today, but I'm doing it for spatial data, so I'm unique. So what's actually going on? Essentially, one of these data structures has DC sort of in this, it's like projected this way, and another one has DC projected this way. Your boundaries aren't matching up because your latitude and longitude are mapping to x and y differently. Latitude and longitude are 3D coordinates, and when you work with x, y, you have to push them down into like a flat surface. There are ways of doing this, and if you push them down in different ways and they don't align up, you can't make a map with both layers. So what we're actually going to do is straighten out and make sure that these two layers are the same. To do that, I'm going to check the projections. So STCRS of the crime layer uses the 4326 EPSG code. And as we expected, the coordinate reference system for DC tracts uses the 4269 code. I think we have found our problem. We can make them the same. This is relatively straightforward. So I'm going to transform DC crime and DC tracts to the Maryland state plane projection. Now, generally, it's accepted there are common projections for each state. Like there are some projections that are better for each state. They like map to an actual flat map better. I do not have these memorized. I have no idea that the Maryland state plane was 102285. I just looked up best projection for DC and found 102285 as my code, so I decided to use it. Now I'm going to check the projections again. DC crime, okay, now the EPSG is 102285. DC tracts, now the EPSG is 102285. They look the same, I'm good to go. So if I try joining again, it works, woo! So you can see that this data structure is still a simple feature collection. Now you can see that I've joined the census tract onto the offense. So now I have the offense and I have its associated census tract on the left. As you can see, there are a number of things in this simple feature collection. It tells you that it's a point geometry. It tells you where the bounding box is, which is the rectangle that surrounds your data. And it also tells you, the coordinate projection system, or yes. So it worked, yay, phew. Okay, now I'm going to go ahead and map the crime counts. So these are just the number of crimes, 0 to 20, 20 to 40, 40 to 60. It looks like certain parts are a little bit more crime prone. This makes a cartographer sad. This map is not great. Why? We're mapping a spatially extensive variable. What does that mean? That means that the count is related to the area of the tract. So you can imagine that if the size of your square is bigger, the number of crimes that happen in it is probably going to be bigger too. We're going to fix this, as we mentioned before, by dividing by population. Right here I'm using the Tidy Census library, which is a wonderful, wonderful package that I just love, and it's so good for social science researchers and anyone who's interested in census data at all. It pulls from the Census API. It gets both census, 10-year census data and American Community Survey data, which is a sample. So I'm getting tract data, I'm looking for population, and I'm getting it for DC, which is not a state, but had to do that for the syntax. Okay, and what does that return? A nice tibble with the GeoID, the census tract, the variable, population, and the census tract. Again. As you can see, there's one row in here that doesn't have very much population. I'm inclined to think that this is the mall, but I'm really, really curious as to why there are 8 people living in the mall. Who knows? Okay, so now I'm mapping crime rates per capita, and this is a much better map. So this is telling me, the crime per 1,000 people, and I took out the mall and I think another one that was just I think people don't live there. I think one of them was a park. Does someone know where that white square is? Anyone know? Any DCers from here? Okay, I took out the mall and something else. What is it?
It might be the botanical garden.
Oh, it might be the botanical garden. Yes, local knowledge. Very important. Okay, so after I made these choropleth maps, so the name for these maps with little squares that are colored in are called choropleth maps. They are not chloro. There's no L. It's just choro. It stands for, oh no, I used to know the Greek and now I don't. Choro? Greek? Someone know what that means? And pleth? It's color? Yeah, color. And then pleth is, I think, area, right? So color area, choropleth. Okay, so I made this choropleth map. Now I'm really curious in my exploratory spatial data analysis to see if crime rates and median income are related. So now I'm not mapping the rate of crime rates, rate of crime. I'm looking at one variable and its relation to another. So I want to grab median income by tract. This I get from the American Community Survey data. It is in the same package, tidy census, but it's a different variable. And now if I look at this data, head of DC income, I can now see that I have the variable and then an estimate of the income, median income, which is quite high, and the margin of error. Don't worry about the margin of error because this is a sample. They have, margins of error on their data. Okay, so now I'm going to go ahead and map crimes and median income. By the way, I'm doing this not in Leaflet, but I'm doing it in TMAP, which is my favorite and preferred mapping package. It was designed by a cartographer, and it really is very extensible. Just like base plotting and ggplot, you can do whatever type of mapping you want. You can do whatever type of plotting you want, as long as it gives you some sort of way to work fast with the data when you're looking at it. I use TMAP because I know it well. You may use Leaflet, you may use ggplot even. You can do maps in ggplot. But in any case, so I've done a quick dive into spatial data analysis. I made a few maps, taken a look at a few things I might find interesting and look at rates. But there's a lot more that I could do. There might be other local demographic and socioeconomic factors that affect crime rates. So I would do this with spatial regression and modeling. Crime in one area might be linked to crime in another area. So I would look at crime rates and see if you have a neighboring tract that has a lot of crime, like what is the effect on you? Because there's probably some linkage there. So that is called spatial autocorrelation. And I might be interested in spots where crime is abnormally high or low. And that would be solved with some sort of spatial clustering, trying to identify hot or cold spots in the city. All right. So just a taste of what spatial data analysis can do for you. If you want to know more, feel free to talk to me. All right.